All right, on the problem 35 and 36 or whatever, you're going to have 1, 1. That's your starting point. Now you're going to add this. So this is basically a vector, but it's also your slope, if you will. Your slope would be negative 3 halves. And then your other one is, of course, parallel to it, so that would be the same. Put a T there, that's how the big kids do. And then 5 and 4. Beautiful. Oops, 5, 4. So the question then becomes, how do I find the distance between them? Okay, well, that's easy. So, boop, boop. And we know we're at 1, 1. And we're at 5, 4, or whatever. Okay. Okay, well, there's a vector here, am I right? Yeah, you see that? So that vector would be 4, 3. True that? Okay, so then think about this. You could then reflect it. You could not reflect it. You could project it onto this vector here. Well, what is this vector? Well, this vector and the other one both are negative 2, 3. You with me? That's a projection of this one onto this one. If this is B, projecting it onto A. Okay, does that make sense? What we want is actually this distance over here, the perpendicular side. Okay, so that's what you're finding. Okay, so then the way to do that, and it's pretty straightforward, is what you can actually do is talk about. It's back on page. It's back on page. Excuse me. Yeah, there it is. Back on page 42, the top of the page. Okay, so where it says, it labels this a little differently. It says, hey, this is V here. That's hot. It says the bottom, of course, is that projection, right? This is the projection here, the projection. And the book writes it this way of D onto V. Oh, projection of V on, I'm sorry, V onto D. There you go. Exactly. That bottom side is basically what I had a minute ago. Now this side over here, and I think with this is pretty exciting here. So when you do this guy, this side over here, by definition, then becomes this. It becomes, first of all, we want to displace, we want an amount. And so it's going to be the magnitude of V minus this projection. Okay, it's the magnitude of it. Now, like, how do I find that? Well, right below that, it always talks about this. The projection of D and the V onto D like this is equal to D dot V over D dot D times D, right? So in our case, exactly what I told you is 3 dot negative 2, 3 over, and now we're doing, so negative 2, 3 dot negative 2, 3. Okay, so when I do that, and then of course, whenever that's all going to be a scalar, we're going to multiply it times this fella. So on top, you're going to have negative 8 plus 9 is 1. On the bottom, you're going to have 4 plus 3 plus 9 is 13. So you're going to have 1/13, negative 2, comma 3. And so there it is. Now, that is negative 2/13, 3/13. Okay. Now, that guy, so what we're going to do is we're going to take 4, 3 minus this guy. Okay. And let's see what we end up with. Well, when you do that, you're going to have, geez, what is that going to be? I need a calculator. So 4 plus 2/13. What? 4 plus 2/13 is 54/13. And 3 minus 3/13 is 36/13. And what we need is the magnitude of that fella, right? So we're going to grab this fella. No, wait, we're going to do parentheses. That guy squared plus parentheses that guy squared. And then square root that. So I'm going to get about 4.99. about 4.99. Again, all we did was take the magnitude of this guy. So a squared plus b squared is c squared, right? And let's see if that makes sense. So that was problem number 35. See if the back of the book agrees with me. See if I'm did something right for once in my life or not. I don't know. Sounds about right though. Okay, so 1.3, number 35. Lo and behold, I got that. The back of the book says it is 18 root 13 divided by 13, and it's 4.99. Bam! Nailed it. Shut, dog. So that's how you do that. Gets easy. The other one is the same problem, except it's in 3 dimensions. I will finish up with the other one later, the 2.4 one. I'm having a real sticky wicket time there, trying to get that that knocked out as far as the what to set it equal to. It's freaking me out a little bit. I did it a different way. It kind of works, but it's kind of half-assed using Excel, and I don't like that. So I will get you a better video for that soon.